Okay, we're going to go ahead and start with 2.2, patterns in linear functions. We're going to be looking at what is a function. What's the definition of a function? Well, a function is a relationship of pairs. So we're looking at two things that can be paired together. And for it to be a function, there could only be exactly one output value. What that means is that whatever I put in for x, I can only get one y if I'm looking at x and y as the values. Okay, so before we get into more into what the function is, the input, okay, in this diagram right here right underneath, shows that an input is the independent variable. So the input, that's going to be known as our x values. And the function can only produce one output. Okay, and there's sense to this. Okay, and I'll bring it up right now. So a function could only come up with one answer. Okay, so, and it doesn't matter how many x's. X could be as many as it wants, but it always has to produce one answer. So the output, that's known as our dependent variable. That's our y value, or our y values. So if one x comes in, so let's do an example. Let's say x is 1, okay, and I get y equals 1. Well, that's good. This is a function. For 1 that comes in, 1 came out. And the most important thing is that 1 comes out. One possible, only one answer could be it. Makes sense, okay? Because you can't give me a solution with multiple answers. You want to be able to just give me the right answer. So think of it that way. Well, let's say I have another one. Let's say x is also -1. So x equals 1 or x equals -1. And you put it in the function, and I end up still with this answer. That is still good. Okay, that is a function. So as long as you get one out, one possible answer, that's fine. The number of x's doesn't matter. Okay, you can have as many coming in. As long as I get one answer, that's okay. That's what a function is. What is not okay is if I were to plug in one or what, if I plug in one answer or multiple answers. So let's say I just put in 1, and what ends up happening is I end up with another answer, say -1. Then here's a problem, because now you don't know which of these is your solution. So by doing that, you're getting yourself in trouble, because now you're telling me, okay, my answer is this and this, and I need one answer. You need to choose an answer, so it could only be one. So just remember that a function is only works when there's exactly one answer. So this will not work. Okay, so that has to be gone. So it could only get one answer. Now, one of the main problems I see with students is they don't understand what is dependent and independent. Okay, they get confused. Is it the x value? Is it the y values? Is it the input? Or is it the output? Okay, I want you to write this down in your notes. I want you to write down Dr. or Dr. ID Dr. ID XY. Okay, what does this mean? It means that my y value is my dependent. The D stands for dependent, and it's also known as my range. My x value is my independent, that's the I, and it's also known as my domain. So it's just a quick way to memorize something, to remember 6 things, and associate it to each other. So that way you know that x is your independent, your domain, y is your dependent, which is your range. So just write this one down on the side, and you can maybe want to name this. So you can go ahead and call this range. This is your dependent. This is your y, and of course this is your independent, and then this is your domain. Okay? All right. Now let's go into a practice problem where we're going to look at functions. Okay, for our first problem, we're going to represent a geometric relationship. In the diagram, what is the relationship between the number of rectangles? So that's going to be very important, because we're looking at a relationship, and that means we're going to look at an x and a y, the number of rectangles, and the perimeter of the figure they form, which are these right here. represent the relationship. Again, we want to know how that relationship is going to be used in a table, words, an equation, and a graph. Okay, so a relationship means they're talking about an input and an output, an x and a y. So what we need to do first is we need to determine what's going to represent our x and what's going to represent our y. X is our independent variable, y is our dependent variable. So the question is, which one's which? Okay? Well, if you look at the number of rectangles, the more rectangles we add, the larger the figure, which means the perimeter gets larger. Therefore, the perimeter is going to be the dependent value. The perimeter depends on how many triangles there are. When it has one triangle, the perimeter is very small. When it has two triangles, the perimeter is bigger. And then the more triangles, the bigger the perimeter. So therefore, we're going to let x be the number of rectangles and y be the perimeter of the figure. Now that we know our x and y, now that we know what's our independent and dependent, we're going to write each pair of values of x and y as an order pair xy. And we're going to start by using a table. So I'll put a blank table here. Number of rectangles is our x. Our perimeter, okay, which depends on the number of rectangles, is our y. And then our order pair is xy. So I want to find the perimeter here of this figure. So to find the perimeter, I will need to add 1 plus 6 plus 6 plus 1. So if I want to find the perimeter, it's really 2 times 1 plus 2 times 6. And that's going to give us a value of 12 plus 2 is going to be 14. So we're going to start by putting one rectangle. The perimeter is 2 times 1 plus 2 times 6. And that'll give us 14. So our order pair is 1 for a number of rectangles, and I get a perimeter of 14. Okay, we're going to do this again for the second one. For the second one, we're going to go perimeter is going to be 2 times, well, now let's look at this length again. Now it's no longer 1, it's not going to be 1, 2, so it's going to be 2 times 2, because it's now 2 of these, the top one and the bottom one. So that's 2 here and 2 here, so it's 2 times 2 plus 2 times the widths, which are 2 times 6. And so that's going to give us 2 times 2 is 4, and this is 12. So 12 plus 4 is going to give us 16. So that means that this would be 2. We will write 2 times 2 plus 2 times 6 equals 16, and our order pair is 2 and 16. Alright, so we're going to repeat that process. And what ends up happening is we're going to fill the table. I'm just going to go ahead and get ahead here. And this is our table. So here are a number of rectangles. Here's our perimeter. And notice something very important. The number of rectangles is associated for our value of what we're plugging here for the widths. So goes with 1, then 2, then our width is 3, then our width is 4, so that goes by the number of rectangles. Okay, so now we have our table. So the next thing we need to do, let me get this out of the way, is, so we have a table now, and now we can go ahead and come up with a description of what's going on here. Okay, so let's go ahead and start describing what is occurring on this table. Okay, so what is occurring here is to find the perimeter, we're multiplying 2 times the number of figures, or the number of rectangles, plus we're adding 2 times 6, which happens to be the width. So in words over here, we're going to say we're multiplying the number of rectangles by 2 to get the total length. And we're going to do that for both the bottom and top sides of that figure, so which is the top here and the bottom here. Then we add 2 times 6, or 12, to get the total length for the left and right sides of the figure. So since it's 12, we're going to go ahead and write this now as an equation of y equals 2 times x plus 12. So we're changing this 1, 2, 3, 4 to represent x, and the 2 times 6, 2 times 6, it says we're going to change that to 12. So that means that's our equation. That's really pretty much what you're describing right here, what is occurring right here. Okay, so you're able to change that where x represents number of rectangles, and then the last part would be our 12. So now the last thing we need to do is we need to use our table and graph it. So I'm going to move this a little bit lower, and then here's our equation, our graph. So our graph is based on the table. Okay, our graph is going to the following. You have the number of rectangles, which is going to be our x value, which is our x, which is our independent variable. So our x-axis goes from 0 to 4, and for the y, the perimeter, well, that's going to be our y value here, our independent, and our values went from 14 to 20. So we need to find something reasonable that fits within that range. So we're going to go from 0 to 24. You don't want to go up to 100, it wouldn't make any sense. And then we plot the points, and there's our graph. So again, you have to be able to break this down into a table, into words, into an equation, and into a graph. So here are 4 ways to describe a relationship. Okay, for the second problem, we are representing a linear function. A table shows the relationship between the number of photographs x you take and the amount of memory y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So on this problem, it's actually a little bit easier because we have the table already given to us. So the number of photos is our x, which means that x is going to be our independent variable. Memory, which is our y, is going to be our dependent variable. So the first thing we need to do is we need to see what are the changes occurring in the graph. So if I look at the x, the only change that is occurring is every time we take a photo, we're adding one more photo. So the x is increasing by 1. If we look at the memory, we went from 512 to 509, which means we are decreasing 3 megabytes. And then it occurs every single time at a constant of 3. So we're reducing every single time by 3 megabytes. So that's going to be very important for us to come up with the equation. So let's start first with what we already learned. The memory is 512 before any photos are taken. The independent variable is x, and it increases by 1 each time. The dependent variable is y and decreases by 3 each time x increases by 1. So for every photo we decrease 3 megabytes. So now we're going to use this to come up with an equation. So in words, what is occurring? Our memory starts at 512, and we are seeing a decrease of 3 megabytes for every quantity, for every value of x that is occurring for every photo. So the words would be the amount of memory left of the chip is 512 minus the quantity of 3 times the number of photos taken. If we change that from words to an equation, we're going to get y, the amount of memory left, is, that's our equal sign, 512 minus, there's our minus sign, the quantity of 3 times the number of photos, and the number of photos represents our x, so 3 times x. So there's our equation. The last thing we want to do now is make a graph. So our graph is now this. So our graph, we're not going to go from 0 all the way to 500, so we'll use this little side line here to represent that we already reached 500 on our graph. And now from 500 we go up to about 512 for a reasonable value, for a reasonable range for the y. For our domain, it's the number of photos, it's from 0 to 3, so we just added one more, so it's from 0, 2, and 4, so that will represent our x values. If we graph this, we find each value. For 0, it is 512. For 1, it is 509. For the second photo, it would be 506, and then for the third photo, it would be 503. Notice that it's consistently dropping by 3 here, 3 megabytes, and then 3 megabytes, 3 megabytes. So what you have here is a straight line, therefore this is a linear function. So this is our last problem for this section. Okay, don't forget to do your summary, and then we'll see you guys tomorrow.